Today we're looking at 902 exponential and log functions. So remember how to sketch the parent function 2 to the x. The y-intercept is 0, 1. 2 to the first power is 2, so 1, 2, and then 1/2 because of the negative exponent. So now I'm going to take those 3 points and do this transformation, which is left 2. So left 2, and left 2. And this will have an asymptote at y equals 0. 1/3 to the x still goes through 0, 1, over 1 up, over 1 up 3, and now at 1, it's at 1/3. So it's a flip over the y-axis, kind of compared to the 2 to the x graph. And then I'm going to shift all of those points up 2 this time. And the other thing that's going to get shifted up 2 is my asymptote. So now my asymptote is at y equals 2. Solving for the variable. I think all of this section is the ones that you can do without a calculator. So 6 to the 0 power is 1. 10 to the first power is 10. When the bases are the same, you can set the exponents equal to each other. T plus 4 equals 6 minus 2t. Add 2t to the other side. So you'll have 3t, and I'm going to subtract 4. So 3t equals 2. So t would equal 2/3. And if you need to slow me down, or if you want to pause me and go ahead and then check your answers, that works. All right, the next one, how do I go from 3 to 1/9? So if I square it, I would go to 9, and if I do the negative second power, that's how I would flip it over at the end. 4 cubed is 64. How do I go from 8 to 4? So one strategy is to do the same base on both sides. So I can change the left into 2 cubed to the x, and this would be 2 squared. Now we can set 3x equal to 2, so x would equal 2/3. The fractional exponent rule. So remember, the denominator is what goes on the outside, and the numerator is your power. And you always want to do the radical first when you're not using a calculator. So 5 to the first power would just give me 5. I can't take the square root of a negative number, so this one will just have no solution. If it had been a cube root, I could have done a cube root of a negative number. So this is the cube root of 27, and then I'm going to square my answer. So the cube root of 27 is 3, and then I'm going to square it to get 9. Like I said, go through this a little bit slower and pause it. I'm just making it quick today. To find an inverse, you are going to switch x and y. So x equals 2y plus 4. Then you're going to solve for y by itself. So my first step would be to subtract 4 to the other side. My last step would be to divide both sides by 2. So I can either write my answer like this, or I could write it as a slope of 1/2 and a y-intercept of -2. So actually going through and dividing each term by 2 if I want to, but you can leave it at this step. This is a log function, and so its inverse will be exponential, as you'll see. So your first step is to switch x and y. Your second step, if there's no base, you need to give it a base. Natural log has a base of e. Common log over here will have a base of 10 when it's not written in. Change to exponential form. So e raised to the x power is equal to y minus 5. So my last step would be to add 5 to the other side. So my inverse will be y equals e to the x plus 5. C and D, no, just C is an exponential function. So it's going to result in a log inverse. Switch x and y. Change it into log form. So the base of the exponent becomes the base of the log. The number that's outside goes inside, and that untraps the exponent. So see how 3 to the y minus 4 still equals x? So this is equivalent. They're just written in different forms, exponential form, log form. So my last step is to add 4 to the other side of the equation. All right, and so D, I'm just going to do it down here so I have more room. X equals the log of y plus 1. Switch x and y. Then make a base if there's no base. Log has a base of 10 and switch it into exponential form. And then your last step is to get y by itself. So this will be 10 to the x minus 1 as your final answer. So evaluating logs without a calculator. So 2 to what power is 64? 2 to the 6th. 3 to what power is 27? 3 cubed. How do I do 10, flip it over, and then get 4 zeros? That would be the negative 4th power, and 4 to the 0 power is 1. Rewriting this in log form, so the base of the exponent becomes the base of the log. The number outside goes inside, and the exponent kind of switches roles and goes outside. When you read it back, this 3 raised to the x power gives you b, so it's kind of this circle. So this one would be the log base 2 of 1/2 equals -1. 2 to the negative first equals 1/2. So to review where the buttons are in your calculator, the log button is right here, log key. So I'm going to hit just the log of 8. Oops, I'm not on the home screen. The log of 8 comes out to 0.903, 2 decimal places, 0.90. The natural log of 5 is 1.61. And to find the change of base key, you go under the math key and you go all the way down to log base. I want the base to be 3 and the inside number to be 2. 0.63 is the answer. Expand the expression into more than one log. So I would have the log of base 4 of 5 plus the log base 4 of x. So when they're being multiplied inside the log, you can split them into 2 separate logs adding together. So condensing, I'm going to go the other way. So this could be written as the log base 7 of 12 because 4 times 3 is 12. Graphing functions. So this says if it helps, graph the inverse first. I'm just going to remind you that a log graph always starts at an x-intercept of 1, 0. And it's going to go in this direction. And it grows by whatever the base is. So if the base is 2, we're going to go over 2 up 1. If the base is 3, we're going to go over 3 up 1. And that's enough to get the graph fleshed out. So if I graph just the log base 2, the graph would look like this, over 2 up 1 and over 4 up 2 and then 1/2. This is shifting everything left 1. So left 1, left 1, left 1, left 1, and that puts my asymptote at x equals -1 instead. And so I'm connecting the x's as my graph. So base 3 log starts at 0 or 1, 0 again, but it goes over 3 and up 1 and over 9 and up 2. It's all powers of 3 this time. This is shifting down 2. So down 2, down 2, down 2, down 2, and I would have an asymptote at x equals 0. Solving on a calculator. If you're in exponential form, you want to change to log form. My exponent is by itself. Log base 2 of 10 equals x. Math. Log base 2 of 10 is 3.32. Again, exponents by itself. The log base 4 of 21 equals x plus 7. So I'm going to evaluate this and then at the end subtract off 7. Math. Log base. The log base 4 of 21, enter, and then minus 7. Negative 4.8. On letter C, first you have to get this log by itself. So my first step would be to add 5 to the other side, making it 7, and then divide by 2. So I really have the log base 3 of x equals 3.5, because I took 7 and divided by 2. So I'm really evaluating 3 raised to the 3.5 power. 46.6 6.8. I am in log form and I'm stuck, so I need to change it into exponential form, so I need a base. The base is e. Natural log has a base of e. E to the 40th power equals 2x. I probably shouldn't have made this problem. This is going to be billions, trillions, not sure how big. So I'm just going to leave my final answer as e to the 40th divided by 2, rather than writing that in scientific notation and it being a humongous number. And the last three here, reviewing our exponent rules. You are allowed to add together the powers if the base is only the same. So I'd have x to the 35th, y to the 6th. When you distribute, you multiply powers. So x to the 8th, y to the 4th, x to the negative 12th. The negative 12, I can slide to the denominator and make it x to the 12th. 8 and 12, 8 of them are going to cancel. So I'm going to have y to the 4th left and x to the 4th left in the denominator because 12 minus 8 is 4. And I'm going to distribute and multiply x to the 10th over y to the 6th for my last problem. And now you're doing the guided practice on the back page. Thanks.